Hello, welcome to another module in the Survey Forge software. This is Trenching Report. I'll get going with a demo. So first I'm going to load a folder. It's all the files that I want. 8 files. All right, and then I'm going to set my DOL threshold. So I want the product cable to be buried lower than 0.6 meters and start the computation. Right, so these are all the files that I've just imported, ingesting by this software, being ingested. So there's the DTM, the seabed surface, the TSS track, which is the product track, an online and supervisor log, and RV track to check the altitude, trencher speed, hopefully not taken from the tracks of the trencher because they can slip, but the actual trencher speed taken from GPS, and the tooltip depth and jet pressure. Right, the computation is completed, so let's have a look at the data in 3D and full screen. So let's see what happened at the start. So if I click on the DTM, you could see the first log, online surveyor, pre-trench checks. And as we went along here, it looked like some good trenching done here. It's above 0.6. So the product is trenched deep enough. And then over here, there's a transition zone. In this section here, it's definitely not trenched deep enough. Let's see what was logged at the transition zone. So here, touchdown watch, shallow cover, developing ahead. And then we can have a look what happened before and after. Scroll around. If we want to see what happened at the end, this is what happened at the end, okay, of this questionable zone. Then what it looks like, we go into a bit of a marginal zone, so the 0.6 target is just about reached, and then back into a area where we're not reaching target. So RV track looks good. I'll take that off. Let's have a look at water jet pressure. So now this color palette is water jet pressure, high in blue, and we see that the high water jet pressure is in the spots where they struggled, which makes sense. And we have trencher speed. Have a look at the trencher speed, high in blue. So it looks like the trencher was going really fast over these difficult areas. So either they decided they could not trench any deeper, or they made a mistake and went too fast. And that's the reason why they couldn't get down to target. And this isn't from the tracks slipping, because this is trencher speed, absolute trencher speed taken from GPS. But this is all made up data. This is a demo, so just to get you an idea of how the report could look. Same functionality here on the side with the logs and the profile. So let's go full screen on the profile, and we'll add all the data. And the same functionality with the logs from the start to the end. And this is a 1 kilometer section. The bottom here is 0 to 1000 kp. This is a bit busy with all this data, so let's just have a look at what we wanted. So we'll take off everything else and leave trencher speed. And as expected, we saw before, the trencher speed is spiking the areas where there are these red dots, which means that the DOL is really approaching the seabed surface here, 10 centimeters below the seabed surface. And here's our target, 0.6. So the trencher is speeding up over the problem areas. Okay, and that that's just an example. Here's the pass report showing how the files that we imported were handled, and some assumptions also about the input data, and a bit more about how the TSS operates, and also here about tracking the top of the cable or the pipe, and we can put in the pipe diameter. Also put in a vertical exaggeration, so we make that 3, and if we go up here, you can see that there was a little bit of a trench left by the cable, by trenching. Here it's like it's a bit of an indent there. This is not the best DTM. In reality, you would have a higher resolution with a few boulders and rocks being displayed around. This is just a demo. So this is the path. We can see the product takes. Okay, and we go down. There's some DOL statistics. The threshold, 68% is below threshold. And some flag segments where it thinks we need to go and do some extra trenching. And a pick point wherever we click on the DTM, we can get all the data here. Some exports. And that's it. So that's a good trenching report just from these raw input files, and the trenching port was constructed, and a little bit of work getting these files together. And this is in 1 kilometer sections. It could be, a kilometer was quite easy to handle. You could have more than a kilometer for each section of the report, but you get the idea. Thanks for watching.